All right, this is lecture 7.4 in pre-calc. At the end of the video, I will give you the homework answers for homework sheet 7.4. And then if you have any trouble with any of those, you can ask me to work on them when school reconvenes. And so 7.4.1 is solving non-linear systems using elimination. Okay, our first example is, let's say we have x squared plus y squared is equal to 9. And we have 2x squared plus 3y squared is equal to 18. All right, so before I start to work this out, this is a circle, this is an ellipse, so they might cross in more than one spot. Okay, so in that case we'd have more than one solution. Let's multiply this second equation by 2. Excuse me, the first equation by 2. If we do that, then I can eliminate the x squared given. So we'd have 2x squared plus 2y squared is equal to 18. And then I'm going to rewrite the second equation right underneath. 2x squared plus 3y squared is equal to 18. We'll subtract the second equation. 2 minus 3 would be negative y squared is equal to, and 18 minus 18 is 0. So y is going to be 0. So I'm going to plug 0 into this first equation and get our values for x. So we would have, bringing this down, x squared plus 0 is equal to 9. So x squared is equal to 9. So x is equal to plus or minus 3. Don't forget the plus or minus. So our solutions, when x is positive 3, y is 0. And then when x is negative 3, y is also 0. So those two functions cross in two spots. All right. Give you a chance to pause the video if you need to. Our second example is 2 over x plus 3 over y is equal to 13 over 6. The second function is 4 over x minus 1 over y is equal to 5 over 6. Okay, we could work with either the x's or the y's. If you were to multiply the top by 2, then we could eliminate the x's. If you were to multiply the bottom by 3, you could eliminate the y's. Either one's fine. I'm going to work with the x's. So let's multiply this top equation by 2. So that'll give us 4 over x plus 6 over y is equal to 26 over 6. Rewriting the second equation underneath, I have 4 over x minus 1 over y is equal to 5 over 6. I'll subtract the second equation from the first. So 4 minus 4 is 0, so that eliminates this column. 6 minus negative 1 is 7, so we'd have 7 over y. 26 minus 5 is 21 over 6. All right, so I'll cross multiply. 7 times 6 is 42 is equal to 21y, so 2 is equal to y. Okay, I'll substitute that 2 into the second equation. Either one will work. So we have 4 over x minus 1 over 2, which is our value for y, is equal to 5 over 6. Let's go ahead and get rid of the fraction by multiplying the entire thing by the least common multiple. So with 2 and 6, I can multiply by 6. I'd have 24 over x minus 6 over 2 is equal to 30 over 6. 6 times 5 is 30. So that's 24 over x minus 3 is equal to 5. 24 over x is equal to 8. So 24 is equal to 8x. So x is equal to 3. All right, so our solution is x is 3 and y is 2. Okay, the next example is we're going to find all of the points where x squared plus y squared is equal to 5 and y squared, y is equal to, not y squared, y is equal to x squared minus 3 intersect. So this function is a circle. This function is a parabolic, so they could actually cross in as many as 4 spots. Just depends where they sit on the graph, so we'll see. All right, what I would do is let's write one function under the other. So for this function, I'm going to pull the x to the left and rewrite that as negative x squared plus y is equal to negative 3. And I'm going to write that underneath our circle equation. So x squared plus y squared is equal to 5. And then bringing this under here, negative x squared. And then there's no y squared, so we have plus y is equal to negative 3. Adding those two together, x squared plus negative x squared, the x squareds go away, then we can just bring down the y squared, plus y, 5 and negative 3 is 2. So we have y squared plus y minus 2 is equal to 0, and we will factor that. So y, and then plus 2 minus 1 will work. So y is equal to negative 2 and positive 1. All right, it's pretty easy now to solve for x. Okay, I'm just going to take this equation, rewrite it as x squared is equal to y plus 3. So just pull the 3 over to the left. And now we're going to substitute in when y is equal to negative 2, x squared is equal to negative 2 plus 3. So x squared is equal to 1. X is equal to plus or minus 1. When y is equal to 1, we have x squared is equal to 1 plus 3. X squared is equal to 4. So x is plus or minus 2. So I've got 4 solutions. When x is 1, y is negative 2. When x is negative 1, y is also negative 2. Okay, Okay, when x is 2, y is 1. And then when x is negative 2, y is also 1. All right, so give you a chance to pause the video and catch up on any of the notes where I was standing in the way. All right, section 7.4.2. is solving nonlinear systems by substitution. Okay, so we used elimination before, we're going to use substitution now. You might like this method better. Sometimes one works better than the other. So our first example is solve x squared minus y squared is equal to 16, and x minus y is equal to 2. So what I'm going to do is rewrite this. It'd be pretty easy to rewrite this as y is equal to x minus 2. So I pushed the y to the right side, made it positive, pulled the 2 to the left side, and then for y we'll plug x minus 2. So we have x squared minus x minus 2 all squared is equal to 16. And we're going to have to FOIL that out. So x minus 2 times x minus 2. So we'd have x squared minus, we're going to put a left parenthesis to make sure we distribute that negative sign, x squared minus 4x plus 4 when we FOIL that out, and that's equal to 16. So we have x squared minus x squared plus 4x minus 4 is equal to 16. The x squareds go away. We have 4x is equal to 20, x is equal to 5. So I can easily plug that into this equation right here. We know that y would then be equal to 5 minus 2, which is 3. So our solution point is 5, 3. All right, I'll give you a chance to pause the video. All right, our last example for 7.4, we have 2x plus y is equal to 7, and x squared plus xy minus 12 is equal to 0. So let's rewrite that top equation solving for y. Y is equal to 7 minus 2x. And then I will substitute that expression in for y. So we've got x squared plus x times 7 minus 2x minus 12 is equal to 0. Distributing the x, we would have x squared plus 7x minus 2x squared minus 12 is equal to 0. Combining the x squared, we'd have minus x squared plus 7x minus 12 is equal to 0. All right, I don't like to factor with a negative in front of the squared, so I'm just going to shoot that entire expression over to the right. So we'd have 0 is equal to x squared minus 7x plus 12. And then we can factor x, and then minus 4 minus 3. So x is equal to 4 and 3. All right, so there's our x values. substitute right back up here for y. We're going to x is 4, y is equal to 7 minus 2 times 4, which is negative 1. When x is 3, y is equal to 7 minus 2 times 3, which is 1. So our solution points are 3, 1, and 4, negative 1. So that concludes the lecture for section 7.4. Give you a chance to pause the video, and in just a second I'll write the solutions down for homework 7.4. The solutions for homework 7.4, number 1 is 5, 4. Number 2 is 0, 9. Number 3 is no solution. Please show your work on how you got there. Number 4 has 2 solutions, negative 1/2, 5/4, and 1, negative 1. Number 5 is 7, 2. Number 6 has 2 solutions, 4/27 and negative 4/27. Number 7 has 2 solutions, negative 7, negative 16, and negative 1, negative 4. And then number 8, 0, 4, and also 5, 9. So again, if you have trouble with any of those, make sure you make a note of it so that when school reconvenes, I can work that for you. All right, so that concludes the video for section 7.4 in pre-calc.